I wanted to break down how to do these problems step by step. So here we have patient's DLP is 2 esophoria, their NLP is 4 EP at 40 centimeters, their PD is 60. Okay, so the first thing we're going to do is draw an eye with an ortho reference line. So ortho. Okay, next, divide the PD by 1/10 of the working distance to get the convergence demand. So the PD is 60. The working distance is 40 centimeters. 1/10 of that is 4, so 60 divided by 4 is 15. And then we're going to draw a line, and that's 15 prism diopters. Okay. Next, draw the distance lateral fourier line, right of ortholine if exo, left of line if eso. So this one is 2 esophoria. So we're going to draw a line to the left, 2 esophoria. Okay, and then draw NLP line, right of convergence demand line if exo, left if eso. So this person is 4 esophoria, so I'm going to draw it to the left, 4 esophoria. Okay, next you can find the value of the NLP in prism diopters, which might help you calculate how much it converged. So uh, I wrote here, subtract foria from convergence demand if exo, add if eso. So this person is 4 esophoria. So we're going to add that to the convergence demand. So 4 plus 15 equals 19. So this equals 19 prism diopters. Okay. Next, calculate amount converged. So when you're doing these problems, you can see that I wrote the forias as dotted lines and I left the reference lines as solid lines. That's because what you're trying to figure out is the distance between these two dotted lines, so this distance right here. Okay, now you kind of have to think this through, but first we should figure out this distance from 2 esophoria to this 15 PD reference line. So if they're 2 esophoria, that means they are already a little bit converged before we showed them the target and they had to converge a little bit more. So they got a 2 prism diopter head start. So from 2 prism diopters to 15, that's 13 prism diopters. Okay, and then from 15 to 19, that's 4 prism diopters. Okay, so 13 plus 4 equals 17. Okay, so that's the amount of prism diopters converged. Next, convert working distance to diopter. So our working distance is 40 centimeters. And then 100 divided by that equals 2.5. Okay, and then finally, we just take the amount of prism diopters converged, which is 17, divided by the amount of diopters, 2.5, and then we get our ACA, which is 6.8. Okay, here's another ACA problem, but this time the patient's 4 XP at distance and 6 XP at near. So again, we're going to start with the ortho reference line. Divide PD by 1/10 of the working distance to get the convergence demand. So 60 divided by 4 equals 15. 15. Okay. Draw distance lateral fourier line right of ortho line if exo. This person is 4 XP. 4 XP to the right because it's exo. Draw the NLP line right of convergence demand if exo, left if eso. Okay, so this one is 6 XP, so we're going to draw it to the right. 6 XP. Okay, find the value of the near lateral foria. Subtract foria from convergence demand if exo, add if eso. So this one is exo, so we're going to subtract. 15 minus 6 equals 9. So this is 9 prism diopters right here. Okay, and then calculate amount converged. So we want to calculate this distance right here. Okay, so from 4 XP to ortho, that's 4 prism diopters. And then from ortho to 9 prism diopters, that's 9 prism diopters. And then we just add them together. 4 plus 9 equals 13. Okay, calculate working distance. Convert working distance to diopters. So working distance is 40 centimeters, 100 divided by 40 centimeters equals 2.5. And then we do 13 divided by 2.5, which is 5.2.